Hi, so in front of you can see the movie gimbal. What I'll do is I'll set up the gimbal for any recording using a phone, a smartphone. So what I do is I set up my smartphone such that my camera is facing the left side of the gimbal, and I'm going to be taking this in a panoramic view. So I set my mobile up, and my gimbal is connected to the STM32 using UART, and I'm specifically using UART 1. As you can see here, the wire goes to the gimbal and to the UART 1. Then I just turn on the gimbal. I just make sure that it's in landscape mode. I press the button, power button, gimbal turns on. So this is the setup. Coming to my STM32, the way the code logic works is that with the included project, the accelerometer, the Freefly API, even gyroscope, all the sensors, all the interfaces, all the communication protocols, everything gets initialized. So all those things are initialized. Then what I do is I look at accelerometer values, I read them, then I compute tilt and roll using these values. So tilt is nothing but the board going front and back, so front and back. So the way I calculate this is I look at the accelerometer data in the y direction, because what I have noticed is that in the board, y direction is facing front, and x direction is facing on the right. So y is like this, front, y is front, x is on the right. This is I found this by debugging. So once I get the y using trigonometry, using taking tan inverse, I get the component of the gravity's acceleration in this particular direction based on the tilt, and that is how I get the tilt value. Similarly with roll, I do it with the x and I get the value. Now inherently these values have certain noise. So what I do is I pass these values through a low pass filter which I have created. What that does is it really smoothens the values, and you do not get you do not get jitter on the gimbal. So yeah, so once my values are being calculated, once they have been filtered out, what I do next is just send them through the Freefly API. So what I do is in the Freefly control, I have set them the control mode as absolute, because I'm sending the absolute angle values. So I did that for the for the roll and the tilt, and I just send them the values normalized to 180 degrees, and it works. What I also do is I clip my angle estimation values with respect to the hardware limits that is there on the device. On the device, the tilt angle is plus or minus 55 degrees, and the roll is plus 110 and minus 90 degrees. So I clip my values. What this does is that when the motors reach their limit, they do not strain themselves to go to a angle value which they cannot physically go. So this is my solution.